So today's topic is EDA using Python, exploratory data analysis using Python. So before going to the practical point of view, first of all, little bit information about the data science I will give. Data science is one of the most powerful technologies in today's digital world. Nowadays, every industry generating huge amount of data every day. Every industry. Every industry means banking industry, healthcare industry, retail industry, every industry. And data science helping organizations and converting data into meaningful insights. So we will see practically how data science converting data into meaningful insights. So that insights the company, the industry is using for the enhancement of their business. So first of all, you should clear about why data science. So one point I can write better decision making. One point. Companies using data science to analyze customer behavior, predicting future trends, improving business strategies. Suppose one bank in this quarter, one bank provided suppose 400 crores of loan, and every bank has a target. Then the bank got profit suppose 100 crores. Then the bank will do the strategy in next quarter how the bank will profit greater than 100 crores. Then the bank will target to the customer. Then how the bank will target to which customer? The particular this customer eligible to get a loan. So that customer information the bank will analyze. Suppose the bank targeting a particular X customer, his salary, his civil score, his IT file, returns details. So taking some features. So the bank analyzing. So the person who is analyzing, so that person is data analyst. Okay, so we will see. So how the data is analyzing by the company, by the industry, and as a result, the industry taking a good decision. So that's why I wrote better decision making, automation, and intelligence. So nowadays, what is happening? Data science combined with the help of AI, which automates, for example, recommendation, fraud detection, customer support. Nowadays, for example, very simple example, I am taking YouTube. Now I suppose I opened a YouTube and I watched one action oriented movie. Then after that, when again I will open YouTube recommending minimum 5 action related movies. And because that is called as a recommendation system, YouTube so have an AI module. So that module recommending without human intervention. YouTube is not interacting with me, but the AI module is predicting. Okay, so that this customer has favorite this type of movies. So that's why that type of or that related movies YouTube is recommending. So this is called as recommendation system. Okay, so in this way, if I will explain one by one, it will take much more time, but I am not taking more time in theoretical part. Okay, so real time basic key points just I am little bit explaining. Real time problem solving. Real time problem solving. Yes, data science. We will see now. We will consider a real time data set. So data science will help data analysis, data visualization, and how the concept of AI we will use. Okay, then overall we got an idea. If I will see what is overall point is simply analyzing data. And today our topic is data analysis using Python. And nowadays Python is very popular, very simple programming language. And especially Python nowadays very popular due to artificial intelligence and data science, because whatever the libraries, huge library, wide range of library Python has, so that libraries especially for AI, artificial intelligence. 10 years before, couple of years before, when the developer simply was developing one AI application, it was very complex. It was very tedious. Simply for creating a neural network, it was taking very complex. But nowadays, within one line of code that we can resolve, we can create a neural network only due to libraries. Library means what? Library means what? Container, package containing so many built-in functions, and every built-in function having a specific purpose, specific functionality. Okay, so code complexity will reduce. No need to write the business logic explicitly. Instead of 1000 lines of code, in single line of code you can get the solution only using built-in things, built-in functions. So basically, particularly for the data analysis or for data science or for AI, artificial intelligence, some libraries that you have to know. Actually, for this point, prerequisite is what basic knowledge of Python programming, and basically some libraries that you have to know. One is NumPy, one is Pandas, one is Matplotlib, and one is Seaborn. So these libraries that we have to know. So if you have knowledge, then that is good. Suppose if completely you are new, so no problem. Directly I will explain when that point will come to our picture. Okay, so these are the libraries that we have to know, and the most important thing is what is our environment, integrated development environment or field. I told you develop an application, you develop a data analysis application, where you will write, where you will develop. So to develop and execute our application, so we need an environment. That environment we have to know. So now, nowadays, there are many environments, various environments playing in the market. So the most suitable environment is Google Colab. You remember lots of environments: Google Colab, Jupyter Notebook, PyCharm, lots of environments, VS Code, lots of environments nowadays playing in the market. So the most suitable environment is Google Colab. I will explain why it is the very reliable and very simple environment. Okay, so in Google, if I will type Google Colab, you see in Google, I just simply I will type Google Colab. Why I am telling it is simple, we will see. So for this environment, no need to download any software, no need to download any software, no need to install any software. Simply, if you have a Gmail account, so happily it will open. You see. So what I did in Google, simply I typed Google Colab. The whatever the first link I got, just I will click. Okay. So when I clicked, then one interface came, and you see there is an option new notebook. There is an option new notebook. Simply I will click. So now Google Colab environment will open. So guys, this is our field. This is our Google Colab environment. Little bit zoom that I'm doing. So this is the cell. Slowly, we will acquainted with all the terminologies. These are the menus, file, edit, view. Slowly, we will acquaint. There is a code option, there is a text option. So in a text, if you will click, so whatever you can write here, so any description, so here we will write. And you see, there is an option on titles. Just I will click here. Simply any name we will give. Okay, so file name. This is optional. Suppose I will write EDA using Python taking. So basically, we have to choose a domain: healthcare domain, banking domain, insurance domain. So in today's session, I have taken a healthcare dataset. So the dataset is heart.csv file for heart disease prediction. Okay, so taking heart dataset, heart.csv file, whatever you can write, taking dataset. Then .ipynb, this is the file extension name actually. Python application file extension name is .ipynb .py. So this is the file extension name, like .jpg, .png, .doc, .pdf file extension name. Okay, so simply enter. Okay, so I hope everybody understanding what I'm explaining. So now this is our environment. Which environment? Google Colab environment. You remember. So for the development of artificial intelligence and data science application, this environment is very suitable environment, very simple environment. Okay, so our target is, so we need to perform EDA, so exploratory data analysis. So how to analyze the data, how to check missing values, some points are coming. So if I will write EDA, so some points are coming. So some points are coming: data set information, data cleaning, data visualization. So lots of points are coming under EDA. First of all, data set information we will get, data cleaning, so checking missing values, checking duplicate values. If the data set having some missing values, how to handle? If the data set have a duplicate value, how to handle? So this is coming under data cleaning. Data visualization, one of the important terminology under EDA. So visualization means we will create plot, so various types of plots, and through the plot we can analyze the data. We will see so how the plot is analyzing data, and from the plot how we are getting various insights. Okay, so we will start directly. We will go to the practical approach, then shift enter. Any question you have, you can raise, you can ask, no issue. So first of all, before starting the analysis part, first of all I will bring a data set. Then question will arise, sir, how I will bring, where I will bring the data set. Okay, so in Google you type heart.csv file, automatically it is coming. There is a repository Kaggle. You remember Kaggle, Kaggle, Kaggle. So any type of a data set, particularly with respect to artificial intelligence and machine learning, so you can get the data set in Kaggle. So I will click. Now you see it is completely the data set we got, and all the information about the data set. So you can download the data set. Already I have downloaded. Okay, so data set is nothing but one Excel file, and file format is comma separated value, CSV format. I will show you. I will show you. And you see, uh, whatever the data set having some columns, age, sex, the age of the patient, sex, gender of the patient, CP type of chest pain, T rest BPS, resting blood pressure, cholesterol, fasting blood sugar, etc., etc. Okay, so already I have downloaded. I can share the dataset in group also. So I have, it will be better. So you keep the dataset in a folder. So I have a folder, dataset folder in my E drive. So I have kept here heart.csv file. So where is heart? This. Okay, so this is my data set. Okay, so these are the columns. This data set already what has validated. Okay, so this data set you can use for learning, for research, so you can do analysis. So this is my data set, and you see it is nothing but an Excel file actually, but format is what? .csv file. Right click, I will go to properties. You see type of file, Microsoft Excel comma separated value file .csv format. Okay, if you will click on security, where I have kept inside the A drive, inside the dataset folder, I have kept this file. So guys, this file I will share after completion of our session. I will share this dataset. Okay, so coming to my environment. So first thing is, I will bring the dataset into my environment. This is the first test. Okay, so how to bring art.csv file into my environment? Okay, you see, so here three underline, you see. Okay, very important things. So I am explaining, I am thinking, suppose you all are fresher, suppose completely new to this. If you know, it will be better for you. So, and if you are completely new, so line by line I am explaining, you listen, and if possible for remembering, you can write everything in your notes. You see there are three underline, you click. Okay, so point is what? How I am bringing heart.csv file into my environment, Google Colab environment. So what I did, so I clicked this three underline, and you see where is my cursor. So there is a files option. Okay, there is a files option. Now I will click. Okay, so here one option is coming, message connecting to a runtime to enable file browsing. Some option will come. Okay, now this option came. Okay, what I did, again I'm repeating, I clicked three underlines, then I clicked, there is a files option, then these options came, and you see where is my cursor. Now I am bringing to my mouse cursor to this uh, point, upload to session storage. You click, and where I have kept, so I will go to that place. So A drive dataset folder, and this is my heart.cs file I selected. Click on open, then click on OK, and you see in this way, so I brought this data set into my Google Colab environment. Okay, so I hope everybody understanding. So now we will start. So this is the first point. Before going to the practical approach, before going to the development, so first you need to bring your data set to Google Colab environment. Now, first point is import libraries. Import libraries. So, guys, import means bringing. So, whatever the libraries currently I was telling, NumPy, Pandas, Matplotlib, Seaborn, that library I will import, because library means what? Currently I told, it is a container containing some built-in functions. For example, if I will ask, why you are going to your library, your university or your college having a library, why you are going? Because you are thinking the library is a such place where varieties of books are available as per our requirement. So for that reason, you are going to library and you are bringing your textbook as per the recommended. Similarly, here NumPy, Pandas, Matplotlib, Seaborn, so containing huge built-in function. We will see what are the points that we will use here. So that's why that library first of all I will import. Otherwise, if the built-in function we will use, then control cannot understand if the libraries I will not import. So first step I will import library. You see first in which way I am importing. One by one I will explain. Import NumPy as NP. So what is this? One by suppose if you are a newcomer, so one by one I will explain. Import is a keyword. NumPy is the library name. As keyword representing alias, alternative name. NP is the alternative name of NumPy. So NumPy is a library. It is a developed things. Please, guys, please mute your noise. Please mute your noise. Listen. Now, was application started. So, guys, please mute your noise. So, NP is the alias of NumPy, alternative of NumPy. NumPy have a documentation. Another session I will start that I have thought actually only on the libraries. So, whatever the NumPy library containing built-in function, every built-in function we will call by np, we will invoke by np. And one point I am strictly speaking, np is completely user defined. Instead of np we can write ramadama sama whatever, no issue. But numpy officials, they have mentioned np, that's why we are using np. So np, I am repeating, np is the alternative, or NP is the alias of NumPy. So why alias, why alternative? As per the officials of NumPy saying, whatever the NumPy containing library or built-in function, that built-in function we will call by NP. Similarly, I will import pandas. Same way, import pandas as PD. PD is the alias of pandas. PD is the alternative of pandas. So pandas library containing whatever built-in function, that built-in function we will invoke by PD. We will call by PD. We will see. Then pandas meant for what, numpy meant for what, everything we will discuss. Then import matplotlib dot pyplot as plt. So guys, directly, so lively I am writing. Okay, so for your better understanding, so matplotlib and Seaborn, two libraries for visualization actually. And matplotlib is a module or a library in python. Actually library term uh, termed as a module. Pyplot is a sub module. Suppose I will write, I can say Bhubaneswar dot Joydev here, that way. So Matplotlib is a module. PyPlot is a sub module. PLT is the alias of PyPlot. That means for creating a plot, whatever the built-in functions, that built-in functions available inside PyPlot. So that's why we are taking PyPlot alias. Though this alias NP, PD, PLT, again I am saying it is completely user defined. Any name you can give, no issue. Similarly, import Seaborn as SNS. Okay, and you guys remember this is the foundation for machine learning and deep learning. Okay, machine learning is a technique to achieve AI. Deep learning is another technique to achieve AI. Machine learning application, that is AI application. Deep learning application, that is AI application. So time will come that I will explain. So we are before machine learning actually. So any machine learning model we will create, so before that the concept of EDA is necessary. Okay, so what I told, coming to our point, in this way I imported four libraries: NumPy, Pandas, Matplotlib, Seaborn. Now I will hit run. You see, this is the run option. Now I will hit run. Okay, now happily it executed. Then next point, next step. So create a data frame. A new term came, data frame. So it is a terminology of Pandas. So this is common for any machine learning application development. Maximum steps are common. So data frame. Next point is create a data frame. So what is data frame? Data frame is a data structure of Pandas. So that what I told again, I'm repeating. Data frame is a data structure of Pandas. What is data structure? Data structure is a way to store and organize the data. Some basic operations we can perform. That is data structure. So data frame is a concept of Pandas. It is the most important point with respect to interview also of Pandas. So data frame we have to create. So taking hot.csv file, so we will create a data frame, and the output of data frame is our data set, or looking like a table. Table means in the form of row and column. You see how to create a data frame. Let my data frame name is DF. Name of the data frame I gave. So there is a built-in function, read underscore CSV function. Okay. Anything parenthesis. So this is a built-in function. So there is a built-in function, read underscore CSV. Read underscore CSV function. And this is a built-in function coming from Pandas. This is a built-in function coming from Pandas. That's why I will call by Pandas alias. So I wrote pd dot read underscore CSV function. And within bracket, within single quote or a double quote, you can write file name. File name is heart.csv. Okay. So how to create a data frame? You remember. So when read underscore CSV function, it is invoking by Pandas alias PD, then it is returning a data frame. We are getting a data frame. Okay, if you write print df, print function is the output statement in Python. So I will hit run. You see, so data frame I got, and there are 1025 number of rows and 14 columns. So simply just giving comment. So for getting nice look and feel, what I'm doing, df dot head function. So in a data frame, there is a concept head function. So head function displaying or returning first 5 records. Now I will hit run. You see, so here now the data frame look and feel is better. Okay, so head function is a built-in function I called, and head function is a such built-in function which is returning first 5 number of records. But control has known how many number of rows and how many number of columns. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 columns. Okay, so it is a data set for a project heart disease prediction. So we will do this project. So last column is the output column actually, target. This variable is output variable. So 0 means the patient having no heart disease, or 1 means the patient having heart disease. So that point will come, then I will explain. Okay, so now just for better clarity, you check it how many number of rows and how many number of columns. Data frame name is df dot, there is a keyword shape. You remember shape keyword. Shape keyword representing how many number of rows and how many number of columns. I will hit run. Okay, and you see 1025 number of rows and 14 number of columns. Okay, now so slowly we are entering to the data analysis part. Now, if we want to know all columns, so already the columns are here, and you see this is one record, but index automatically generating zeroth index record. This is the first record. One index record, this is the second record. In this way. Okay, so if I want to get all columns, data frame name df dot columns. So I got all columns. Okay, so now we will move forward. So if you want to get the detailed information about my data frame, to get detailed information info about data frame. So what I will do, there is a built-in function info function. Data frame name is df dot info function. Okay, info function is a built-in function, very simple. One line of code I am writing, I am executing, and I am explaining. So easy to develop, easy to understand, easy to run. So that's why it is simple. So info function I called, I will hit run. You see, so what we got, the information about our data frame we got. There are 1025 entries, that is 0 index to 1024 index. These are the column names, and these are the all, each column having no null value. That's why it is displaying non null. This is the D type, meaning is a data type. So each column containing which type of a data item, int is 64. In Python programming, actually the programmer not using data type explicitly, but data type available. So int 64 is the data type. So each column containing integer value. So it is mentioning each column containing int 64 types of data items. So all are integer, only one column old pick it is containing float values, float 64 types of data items. You see D types, one column float 64 types of data item, and 13 columns containing integer value or int 64 types of data items, and memory spaces used in 112.2 KB. So this is overall information about my data frame. If I want to get the information about my data frame, then which function that I will call? Info function. Data frame name dot info function. Then I will go to the next point. If I want to get some statistical information, to get statistical information, statistical details, so about the data frame. Okay, so how to get statistical information about my data frame? So data frame name df dot describe. You remember some built-in function. Everything is simple. Only need practice. Okay, so you after completion my session, you do the practice. So df dot describe function. Describe function is a built-in function. Now I am invoking. Okay, so I will get some statistical information. I will hit run. You see some statistical information we got. For one column, I will explain. Then same way other columns. You see, first count. There are no 100, 1000, 1025 number of values. This is the statistical mean value, standard deviation value, minimum value. This is a maximum value. And regarding 25%, 50%, 75%, so I am saying, remember, in each column, 25 percentage of values or 25% values of each column are less than from 48. Similarly, 50% values of each column are less than from
Uh,
56. Yes, any question? Yes, yes, you ask.
Sir, I'm trying to asking from 15 minutes, sir. Mic was not working right there.
Okay, okay, then you ask us. No issue, no issue. You ask.
Sir, that data pre-processing part, I'm not properly understand. So can you explain that?
Yes, yes, data. This is data pre-processing. Slowly, slowly, we will enter to the data
So
cleaning.
starting 3 point data visualization pre-processing, that part I want to know.
Yes, yes, we will do everything. Data, we just data cleaning. I will start, then I will go to data visualization. So I am explaining to all candidates, those who has no idea, those who have some idea. If you have known, it will be better. So after that, I will go to data cleaning. Then after that, I will go to data visualization. Then after that, I will go to model, machine learning model. So everything that we will cover one by one. Okay.
Sir, here we are only data extracting, right, from the data sets.
Yes, yes. Currently, we will go to the data cleaning part. Okay.
Okay, sir.
Now, simple information I got. Now, currently, we are getting some statistical information. Then, after that, we will go to data cleaning part. Okay. So, guys, you remember 25 percentage of age value are less than from this value. 50 percentage of 50% values of age column are less than from these values. Similarly, 75 percentage of age value are less than from this value. Actually, if I will explain about this, so it will take another 1 hour. Actually, this is q1, q2, q3 actually. So this is another factor actually. But currently, you remember in this way, or in which way I told. Okay, then this is very common steps I did for every machine learning application, or for every EDA part, or for every data analysis part. Now we will go to data cleaning part. In data cleaning, two things basically we will give the focus. First of all, we will checking missing values or not. If there is no missing value, then no issue. If there is a missing value, so how I will handle, maybe some row, maybe some column, or maybe some value I will remove, I will drop, or maybe instead of that missing place, I will represent, or I will specify, or I will fill any mean value or median value. So this is the first point of data cleaning, checking missing values. So how to represent, or how I will get the missing values? For that, there is a one built-in function, is null function. Is null function. Okay. So is null function is a such built-in function which is returning a boolean value, whether it will be true or false. You see, now I will hit run. See, all are false, false, false. False means no missing values. False means no missing values. If I will add another function, some function, and I will hit run. You see, column wise, so summation number of null values if available, their summation we got. H column 0, that means H column having no missing values. Similarly, sex column 0 having no missing value. In this way, so no column having a missing values. So if the data frame columns having no missing values, then nothing means how to handle the missing values. We will not go to that part. Then we will check immediately any duplicated data items present in this data frame or not. So we can check duplicated, duplicate data item, check duplicate data item. Okay. Similarly, I can write data frame df dot, there is a built-in function duplicated. There is a built-in function duplicated same way. So if I will add by invoking some function. Okay. So which function that I invoked, duplicated function, then dot some function. Now I will hit run. And you see 723 simply I will write within a print function. Oh, so already though it has calculated print. So I got 723. So that means 723 duplicate data items available in our data frame. So if duplicated data items that we found, so what we will do immediately, we can drop that duplicated data items, because this is the foundation for machine learning. So when model we will create, so model will require a neat and clean data set, because model will predict very properly. So then, so I got 723 duplicated data items. So immediately, then how to handle this duplicate? So I will drop duplicate. So I will drop duplicates. So what I will do? So there is a function. You see how the concept of pandas is very important, because every point data frame dot something, data frame dot something. So data frame so is one of the most important terminology of pandas with respect to interview. So now df dot, there is a built-in function drop underscore duplicates. Drop underscore duplicates, one built-in function. So this function, when I will call, so duplicate data item will remove, and within parenthesis, one parameter I will pass in place equals to true, because permanently the data frame will update. Okay, in place equal to true. So this parameter now I specified. So after removing the duplicates, whatever updated data frame that we will get, so I can write df dot head function. So permanently update that we will get. So for this, so that parameter I passed in place equals to true. Now I will hit run. You see, so this is again another after removing duplicated data item that I got. Okay, so I hope everybody is understanding. So what I did, first of all, I checked whether the data frame having missing value or null values or not by invoking is null function dot sum function. Similarly, after that, I checked so the data frame having duplicated value or not. So in this way, by invoking duplicated function dot sum function that I got, then I got 723 duplicates. Then immediately I dropped that duplicate at I. Now we will move forward. Now the time came, we will go to data visualization. Some plot we will do. So first I will find the target analysis. So one column is target column, last column is the target column. Okay, and this column containing two values. One is 0 and one is 1 actually, because actually this
Sir,
yes, yes.
sir, is there any command or for methods to know the places of duplicated values?
Places of duplicated values.
Yes, sir. Yes, sir.
No. If there is no missing, if you are finding missing values, you can place. But mean value, median value, this. But instead of duplicate, so it will be better duplicate data item removal. That is, I think, that is a better option. If there is no value, we can place either a mean or a median or any value. Not any value we cannot place as per the concept. But if we have a duplicate, then it will be better we can remove. Okay.
Okay, sir.
Then we will go to the visualization part. So first of all, we will see target analysis. So already we have a real-time data set. Already there is a output column, target column from the beginning. Already I have told, and this data set is for actually binary classification. Binary classification meaning is 0 or 1. The candidate or the patient having heart disease or not. So I will count. Okay. So how I will count? So one plot I am creating, and for this there is a one built-in function, count plot function. Which function? Count plot function. And this is a function, built-in function coming from Seaborn library. Seaborn library. That's why I will call by Seaborn alias sns.count. And this is a built-in function. So this function, if you type in Google count plot function in Seaborn, the entire documentation you can get. This function taking many parameters as arguments, but mandatory argument is, so definitely for creating a plot we need some data items in x-axis or y-axis. Okay, so x equals to, so I took target. That means the target column value either 0 or 1. So it will what display in x-axis. Then comma, data equals to df. Data frame name is df or data frame is. So this is the official if you will go through the official documentation of count plot, so you can find the details. We are not writing anything of our own, whatever, because it is a built-in function as per the function para argument. So that argument, number of argument I am specifying. Okay, so coming to the point. So now, so one title function, one title I am giving. For this one title function I am putting, suppose let it heart disease, whatever you can write. Heart disease, heart disease count. Then so plt dot show function for displaying the plot. Show function I am calling. That you see, title function and show function coming from pyplot library. So that's why I am invoking by plt, and count plot function coming from Seaborn library. That's why I am invoking by SNS. Now I will hit run. You see one visualization came and or one plot came. You see, you see this is a plot. My title is heart disease count. and this is the x-axis data item. Value is 0 and 1 because we have written x equals to target column value. This is 0 and 1, and this is counting. So 0 means no hard digits, so 120, near about 140 candidate patients, near about 140 patients have no heart disease, but one near about 160 plus having heart disease. So this is counting. Okay, how many number of patients having heart disease, how many number of patients have no heart disease. So I hope everybody is understanding. Okay, then we will go to the next plot. Suppose one this is a one plot count plot. There are various plots in Matplotlib and Seaborn. So one another plot I am showing histogram. Suppose my intention is, suppose age distribution. Okay, so I want to know the frequency of age through the plot. So you remember when particularly distribution, there is a term when that type of point is coming to our picture. So which type of plot we have to create? Histogram. So histogram concept already present in Matplotlib, also present available in Seaborn. So there is a function available in Seaborn. That function is histplot. That function is histplot, and it is a built-in function coming from Seaborn library. That's why I am invoking by Seaborn alias. Then taking which column values? Age column, df of age, df of age column values. In this way, I can write. Okay. So similarly, one title I will give for this title function. I will invoke. Let whatever I can write age distribution, then plt dot show function. Now I will hit run. So you see one histogram we got actually. Okay, this is the range 30 to 40, 40 to, so counting actually. So heart within 40 to 60, so T plus age. So actually, what is the purpose of this plot actually? How the age data is distributed. Basically, we say that is the frequency of values. Which age group appearing most? So group means you see this is a 30 to 40 or 40 to 50, 50 to 60, 60 to 70. Okay. So which group is appearing most? I think 40, 50 to 60 in this group. So is, so it is appearing most. Okay, so overall it will represent the age distribution, age frequency, which age group appearing most. So this is the purpose of this plot. Okay, similarly, by taking one column, there is a, I think there is a column cholesterol, one point df dot columns. Just I am bringing all the columns. So I think there is a column cholesterol. Just we will see. Yes, cholesterol. So we can see cholesterol rating higher rate or lower rate, everything that we can see. Same things, cholesterol analysis. cholesterol analysis. So same thing, the this code just I will copy and I will paste here. So instead of H column, I will represent CHOL. Okay, cholesterol distribution. Now I will hit on, you see cholesterol distribution. So the rate within uh, which group 200 to 300 rates. So it is appearing most. Okay, so there is a rate actually. This is the cholesterol values. This is the cholesterol distribution. Similarly, we can analyze the gender to analysis. So means number of male and female, same things, same code. Just I will copy and I will paste here. So I will write gender analysis. So gender analysis, no, it will be better. I will call count plot function. I can count plot function. I will invoke, but count plot function parameter is different. We have to take x equals to one column. You see in my column. So there is in my data frame there is a column sex column having two value. One is 0 and one is 1. Okay. So I can write x equals to sex column name. So data equals to df. And this is the gender distribution. Okay. So now I will hit run. Okay. So this is the gender distribution. Sex 0 meant for what, 1 meant for either, 0 meant for we will consider what, female, or 1 meant for male. Then female, number of female is this, number of male is this 200 plus, and number of female is 100 hereabouts. So this is gender analysis or gender distribution. So here two plot we studied. One is count plot and one is hist plot or histogram. Then we will go to one of the important plot, Heatmap. So one of the important terminology that we will see. Heatmap. So what is the meaning of Heatmap? So I can specify a point, correlation, correlation Heatmap. Actually, before going to the Heatmap, we should know about what is a correlation matrix. Okay, so correlation matrix is a point of data frame. So it is a matrix. So particularly which is establishing, particularly if the correlation matrix is a matrix containing some values, and taking that matrix values, if I will generate a heat map, so that heat map will represent the relationship between a variable and a variable, column and a column. We will see. This is an important terminology and it is very important in data visualization sector. So first of all, okay, so heat map is another plot, histogram is a plot, count plot is a plot. There are various plots. So in one session, I will take especially for what, Python for data science and AI. Only four libraries I will explain. Plot, various plots, bar graph, histogram. scatter plot, box plot, count plot, heat map, so relational plot, categorical plot, various plots quite available in Matplotlib and Seaborn library, but we are plotting whatever the points coming to our picture. Okay, so first of all, what I'm writing, PLT, there is a function, figure function. What is the purpose? And one keyword I am writing, fixed size equals to, okay, so 12 comma 8 I wrote, whatever you can give. What is this? Fixed size means 12-inch width and height. So I am creating a plot. This is width and this is a height, in this way. One size that's explicitly I am representing. Now I will call hitmap function. There is a built-in function, hitmap function. Okay, hitmap function. So for creating hitmap, so this function we have to call, we have to invoke. Since it is coming from Seaborn library, that's why I will call my Seaborn alias SNS. So I am writing sns.hitmap function. Then hitmap function, you see what are the parameters that I am taking. So correlation function, correlation, how I will find correlation. So correlation, currently I was telling it is a matrix. So for this, I will get df dot corr is a built-in function. It is one parameter. Df, that my data frame name, dot. For getting correlation matrix, okay, so which function that I am calling, corr function. Then taking this matrix value, okay, so heatmap will create some, actually heatmap is a such type of plot which generate actually quite some color intensity. So various color it will generate, and each color representing one value. But if I will pass another parameter, comma, if I will specify another parameter and not equals to true, so inside the box, number will display. I will show you whatever the matrix. So the it will visualize in what it is looking like a box. So inside the box, explicitly number will display if I will pass this parameter and not equals to true. And CMAP is another parameter. It is for what, representing color palette. Suppose one color palette, cool, warm, whatever. This is optional. Now, PLT, just one title I am giving. So, correlation, if I will write correlation heatmap, then I will show. I will call the show function for displaying plot. Now I will hit run. You see, this is a heatmap. This is a heatmap. If I will not write, if I will not mention and not equals true, so this is a box and it is a one color. This color representing one value minus 0.22. So and not equal to true. This parameter representing inside the box, this value will display. Okay, so it is a matrix values, but various types of colors in the form of various colors it is visualizing. And maybe question will arise, sir, what we are getting insights, so how the data, how we are analyzing? Yes, we can analyze. So how we are analyzing, you see the column age, because it is establishing the relationship, it is establishing the relationship between variable and variable. You see, age is a variable, target is a variable, or basically in our context we say feature. Okay, so age and target. sex target, CP target, T rest BPS target. You see, this is chest pain. One insight I am showing. This is a chest pain. Chest pain. It is a positive relation. Actually, this is a positive value 0.43. So positive value representing positive relation, negative value representing negative relation. Okay, positive value representing positive relation, negative value representing negative relation. But from the positive value, what we will get insights, because positive value chest pain uh, target, the value relationship is 0.43. That means high chest pain, we will consider the candidate, the patient having high chest pain. So, for if we will predict a heart disease, so definitely we will predict for heart disease. So it is a positive relation. Okay. So similarly, there is a thalak. This column and target column, there is a positive value. Here there is a positive value. So positive value, so representing patient seems to be heart disease. Okay, so I hope in this way we can do the analysis, because particularly from this type of plot, heat map, establishing the relationship between the variable and variable. From this heat map, we got clarity. What the target, the target column and chest pain, the target column, the target and chest pain having a positive correlation. So this is our what insights. This is our analysis. Okay, so this is all about data visualization. Okay, then what? Now the time is 8:47. Okay, we can go for machine learning model. Actually, so we will create a model, and the model will take our data set, and the model will predict which candidate having heart disease or not. But already the data set is given. Suppose this is my, I will consider actually this, suppose this is my input. So this input I will provide to the model. So if the model will predict zero, zero means no heart disease, then it's okay. Accuracy is 100% because target is zero. So this is actually actual data set, and this target column is, this is the actual output. So what is the concept of machine learning? Machine learning is an approach to achieve AI. So we will create a machine learning model, and that model will predict by taking this data set. Overall, I am saying, and especially uh, when the problem statement output having two values 0 and 1, so which is meant for classification. Suppose a problem statement is given, and we have to find out whether the patient having heart disease or not, yes or no, 0 or 1. So basically that is the concept of classification, you remember. So in machine learning, so again categorized into three types: supervised machine learning, unsupervised, and reinforcement. So little bit information just I am giving. Actually, this EDA is the foundation for machine learning. Actually, machine learning categorized into three types. Actually, okay. So one is supervised machine learning, unsupervised machine learning, and reinforcement machine learning. Okay, so supervised machine learning meaning is actually by taking the value of x, we will find the y equals to f of x. So this x means independent or input variables. Y means dependent or output variable or target variable. Overall, this is the meaning of supervised machine learning. Okay. So what I told, machine learning categorized into supervised. Overall, I am saying supervised machine learning, on supervised machine learning, reinforcement machine learning. Supervised machine learning meaning is taking the value of x, we will find, actually we will find means the model will find. Okay, model will find actually what, whether the patient having heart disease or not. Supervised machine learning again based on two concepts. One is regression and one is classification. One is regression and one is classification. Okay, regression meant for numerical value or continuous value. Regression meant for continuous value, whereas classification meant for categorical value. Continuous value means suppose 2000 square foot area price is 5 lakhs, 4000 square foot area price is 7 lakhs, then what will be the price of 6000 square foot area? So whatever the output value we will get, that is a continuous value. Classification means categorical, 0 or 1, yes or no, 0 or 1 or 2, 0 or 1, that is binary classification, 0 or 1 or 2, that is multi classification. So here heart disease prediction coming under binary classification, 0 or 1. Okay, so there are some algorithms coming under regression. There are some algorithms coming under classification. So one algorithm is logistic regression. I am not going through the detail of that. Overall, I am saying logistic regression. There are so many classification algorithm: logistic regression, support vector machine, decision tree, random forest. So many classification algorithms. So we will choose one algorithm. Suppose one is logistic regression. But before that, if I will enter to the machine learning part, but first of all, from whatever the data set we have, so from this, we have to find input and output. Okay, input and output means independent and output. Output definitely last column is the output column. So this column, the output column, and this column is our what, input. Okay, so I can write. So what is x, uppercase x, and what is lowercase y? Independent variable identified by uppercase x, output variable or dependent variable or target variable identified by lowercase y. So, so how to find? So this is the column. There are various ways I can find. Either I will drop target column. There is 1 minute. So little bit analysis we will do. If I will drop all these columns, sorry, if I will drop this target column, then I can find all this column that I will assign in X. and directly if I will target df of target, so that is my also y value. Otherwise in data frame concept also there is a iloc method. So various approaches that we can find, or we can what retrieve input variables and output variables. Suppose I will what draw target columns. Sorry, if this is the column axis equals to one, particular from column removal actually, uh, df. Okay, so now what I did, I dropped target column. So axis equals to one, this parameter you remember it is representing column removal. If I will remove the column, so one parameter you have to pass axis equals to one. So target column, this if I am removing the remaining columns age to this, so I assigned in a variable that is x. Similarly, target column directly df of target that I will consider as y. So I hope everybody is understanding. So from my data set, I found, or I considered which columns are input variable, or which variables are input variables, and which column or which variable is output variable. Then, according to the concept, the whole data set I will split data set into a training and testing data set, training and testing data set. This point you remember, this point is very useful in every machine learning application. What I told. So after choosing x and y, independent variable and dependent variable, so the entire data set I will split into training and testing data. Training means all data set, all data, sample data are training data. Then from all data, I will choose 15% or 20% or 35, 30%. So I will choose as testing data, because the model actually work on testing data. Remember, if in Google, suppose if there is a method train test split. So if you will, so there is a library scale learn. So if you will go to the official document, everything is available actually, and there is a library scale learn, scikit learn. You remember one point: without scale learn library, the entire machine learning is meaningless, because everything we are getting from scale learn. So so what I told, my objective is whole data set I will split into training and testing data. So how I will do. So for this, there is a built-in function train test split. This is the official documentation. So first of all, I will that function I will copy. So sorry, I will import. Then that built-in function I will call. Just I imported first. Train test split. Train underscore test underscore split is a built-in function. So first of all, that I will import. So where I am importing, there is a library scale learn. So dot model underscore selection. It is a sub module. If scale learn is a module, so model underscore selection is a sub module. So from this, I am importing this. So this is a there is a built-in function train test split. Just I am going to the official documentation, and you see. So this is what I will explain. So I will call this built-in function. So it is a built-in function, and when this function is invoking, it is returning 4 NumPy arrays. Actually, it is returning array x train, x test, y train, y test, training data, testing data. So x is input, y is output. Again, it is splitted x train and x test. So this is my input. In input, this is my testing data. So model will take this x test data, and over x test model will work. Similarly, y train, y test. This is y test means actual. This is actual data set. What it is given. What model will predict? Let y prediction. Suppose model will predict this value and this value, we will compare. If the accuracy will be good, then our application is okay. So train test split is a built-in function taking some arguments. So x input variable, y output variable, test underscore size is a keyword. Suppose 33% it have taken. Suppose 25 or 30% you take. Suppose. Okay, it will be better 15% to 30% within that interval. Try to keep. If I will take 25%, no issue. And random state is a parameter which is any positive value. So this is optional. Lots of parameters, lots of arguments. If you will go to the official documentation, that you can get. And it is a such built-in function. It is returning 4 arrays. So this array in Python basically it is called NumPy array. You see. So happily it executed. You see. So if you will write x print x test data, x test. So this is my input. This data is my input. The model will work on this data. If I will get print, simply you write y test. So this is what, this is what. So actual result already in available in your data set. So actual result, actual output. One means hard digits, zero means no hard digits. Actual output and model, we will see what model will give the output. Just we will in between we will find the accuracy. This is the objective of machine learning application. So now the time came, I will create a model. Create a model. So especially which algorithm we have considered. Let it first classification algorithm, logistic regression. Logistic regression model. Create a logistic regression model. So how to create a model? So this model actually it is called as machine. First model I will create, then model will be trained. Once model will be trained, then model become intelligent. Once model become intelligent, then model will resolve our problem statement. So artificially we are creating the model. Then model is becoming intelligent. Hence the term is coming artificial intelligence. Okay, overall I am saying. Okay, so now how to create a logistic regression model? How to create a logistic regression model? You remember simply. So here Python OOPS concept came. Logistic regression is a built-in class name. So from sklearn, sklearn library, it is a library dot linear underscore model. It is a sub module. From this module, I will import logistic regression. Logistic regression. Okay. So in Python programming, so there is a OOPS concept how to create an object. Object name equals to class name parenthesis. So this is the what Python object oriented programming concept how to create an object, how to declare an object. Simply object name equals to class name parenthesis. So guys, you remember, so logistic regression is a built-in class. L is uppercase, R is uppercase. Naming convention, class name, first character is uppercase. If the class name consisting multiple words, first character of the next word is uppercase. So this logistic regression I imported. What I will do, simply I will create an object of logistic regression. Okay. So object name, whatever you give, Ramadamasam, whatever. Suppose I will give the model object name equals to class name, logistic regression, class name parenthesis. Now, this logistic regression object representing logistic regression model. Okay, so how to create a logistic regression model? Again, I am repeating. So logistic regression is a built-in class name which is coming from linear underscore model. This submodule, and this is a submodule of sklearn module, sklearn library. It is coming. So logistic regression I imported. Simply I created an object of logistic regression. So how I am creating object name equals to class name parenthesis, name of the object whatever I can give. So now I will hit run. So now this is the logistic regression model that I created, and logistic regression model name is model. So after logistic model creation, so I will train the model. Train the model. So train. So how to train means the model whatever you are creating, you have to model have to fit. So model name dot, there is a built-in function fit function. Fit function is a built-in function coming from logistic regression class. That's why this built-in function is invoking by logistic regression object. So here logistic regression object name is model. So I am writing model dot fit function. Okay, so fit function taking two argument, you remember, x train comma y train. So this two argument the model will take. Now I will hit run. You see, so happily if this type of output is coming, so logistic regression model trained. Now after that, so now model will predict. So predict function. So model dot predict. There is a predict function, and taking which data, x test data already I have told. So already I have told X test data, model will work on testing data. So let it whatever the model will predict, that prediction result, I will assign in a variable, let y prediction. Let y prediction. Okay. And you see, so print y prediction. Okay, y prediction. Now I will hit run. You see this output we got. So this is the output of logistic regression model, and it is a prediction. Okay, data is analyzing, we are getting what model is giving prediction. That prediction we will implement in our strategy, in our business. Now this is the prediction output, and this is the output of model, logistic regression model. But our actual output this. So now y test and y prediction. So simply we will find what accuracy. If I will find accuracy, then it will be better. There are various ways that we can find the accuracy. So accuracy, there are various ways, but one point I will show you. Okay, so I hope till now everybody got clarity. Again, I am repeating. So after data visualization, we entered into the machine learning. First, we what identified, we considered which columns we will take as input and which column I will take as output. Then whole data set I split it into training and testing data. Then I created a logistic regression model. Then I trained the model. Then model predicted. So after predicted, very simply, so accuracy score. Okay, so for this, accuracy score is a built-in function from sklearn from sklearn dot. So there is a everything is coming from sklearn library. There is a metric sub module import accuracy score. So accuracy score is a built-in function. So directly within print function output statement I am writing accuracy score. It is a built-in function. So taking two argument definitely what model is predicting and what y test actual output. Y test comma what model predicted. So model prediction that I have kept in y prediction variable. Y prediction variable. So now I will hit run. So accuracy is 81%. Okay, so whatever the logistic regression model we created and the model predicted 81% accuracy. So y test and y prediction we compared. Okay, so this is all about the today's session and